So our next topic is around counting methods, also called combinatorics. We're going to learn a number of techniques for easily considering how many different ways could things be done. So the first thing we need to get straight is the idea of the addition and the multiplication principles, and these are relatively straightforward really, but it's just about getting you thinking quite consciously about what you're doing. So generally in dealing with a problem, if you are able to use the word or, there's an indication there that we need to add the possibilities. So for example, if I was to say Jeff is choosing to have either a pizza dish or a pasta dish, and if I knew that there were 7 pizza dishes and 5 pasta dishes available, then clearly he has a choice between 12 different dishes. Alternatively, the multiplication principle, when you could use the word and, you're generally going to look to multiply the possibilities. So for example, if Jackie plans to have a pasta entree and then a pizza for main course, and again there are 7 different pizzas and 5 different pastas available, how many meal choices does Jackie have? So because she's going to have both a pizza and a pasta, we're going to multiply together the number of options of pizza and number of options of pasta to get 35 total choices. And really this is about, if you were to think about drawing a tree diagram here of what might happen. So the first stage of the tree diagram would be her entree choices, her pasta choices, and she's got 5 different pasta choices. So there'd be 5 branches at the first stage of the tree diagram. And then for each of those different entree choices, she then has a choice of 7 different pasta choices. So you would then, from each of those initial 5 branches, draw a further 7 branches branching out. And the result would be that there'd be 35 different branches at the end of the day. So, you know, she could have the bolognese followed by the Hawaiian pizza, or she could have the bolognese followed by the capricciosa pizza, or she could have the carbonara followed by the margarita pizza. And so there'd be all the 35 different options of what she could have. So we're generally looking at or indicates addition and indicates multiplication. Let's have a look at some examples. So John is selecting an outfit. He has 5 different pairs of pants and 8 different t-shirts. How many outfits are possible? So he's going to wear pants and a t-shirt. So we're going to need to multiply together the options here. So he has 5 pairs of pants and 8 different t-shirts. So altogether there is 40 different outfit combinations that he could wear. Mary, on the other hand, is selecting an outfit, and she has 4 different pairs of pants, 3 different skirts, and 10 different t-shirts. So whilst up here with John, he was going to wear pants and a t-shirt. Mary's going to wear pants or a skirt. So that's going to be her first choice. And then she's also going to wear a t-shirt. So there are 4 different pairs of pants and 3 different skirts. So all means we're going to add. She's got 7 different options for her bottom half. And she's also going to wear a t-shirt. So there are 10 different t-shirts she could wear. So 7 different bottoms and 10 different tops. And so therefore she has 70 different outfit choices. Okay, so there are 3 different roads joining towns A and B, and 4 different roads joining towns B and C. In how many different ways could one travel from town A to town C? Okay, so you're going to go from town A to B and from town B to C. So you need the number of options of getting from A to B, which is 3. So we're going to go A to B and B to C. So we're going to have 3 options for this, and indicates that we multiply 4 options for this. So there's 12 different routes that you could take to get from A to C via B. Okay, here we have another road system. In how many different ways could one travel from P to Q? Alright, so there's more options here. So we could go from P to Q going via A and B. So we could go P to A to B to Q. Or we could go P to C to D to E to Q. Or we could go P to F to Q. Okay, so we're going to have, if we're travelling from P to A to B to Q, there's only one way to get from P to A. So we need to go from P to A and also then from A to B and also then from B to Q. So we need to multiply together the options along the journey. So there's only one option to get from P to A. There's 3 options to get from A to B, and then only one option from B to Q. So there's 3 different ways we could travel via AB. P, C, D, E. So P to C there's only one option. C to D there's 3 options. D to E there's 2 options, and E to Q there's 1 option. So there's 6 different ways we could travel from P to Q via C, D, E. And from P to F, only one option to get from P to F, and then 2 options to get from F to Q. So 2 different ways we could go from P to Q via F. So therefore, the total number of total different journeys that could be taken. We've got OR here, so we're going to add 3 plus 6 plus 2, so there is 11 different ways. Obviously in a diagram like this, yes, you could probably count them, but we're starting to think about methods that are going to generalize out to situations with much larger numbers where, you know, just simply being able to count it or work it out in that way is going to be tedious. Okay, example 3. 4 teams are involved in a tournament in which first, second, third and fourth places will be determined. How many different outcomes can there be? Okay, we'll look a lot more at these sorts of problems as we go along through this topic. This is a fairly common type of a question. So one technique that we often use is to sort of use a pigeonholing kind of technique. Think about the different positions that are available in the problem. So here we have 4 different positions. First, second, third and fourth. Now we need someone to come first and someone to come second and someone to come third and someone to come fourth. So we're going to multiply together the options for each of those. So we want to think about, okay, how many possibilities are there for someone to come first? So there are 4 teams in the tournament. Any one of those 4 teams theoretically could come first. Then we think about, okay, well, how many teams could come second? Now given that someone's already come first, there's now only 3 teams left that could come second. And we continue that down the line. So there's 2 teams remaining that could come third, and therefore the 4th position is filled once the 3rd position is filled. And so 4 times 3 times 2 times 1 is 24 different ways that the 4 teams could finish in the tournament. Okay, a safe uses a code that is made up of 1 letter followed by 3 digits. How many possible codes are there? Okay, so again, I've got sort of 4 positions I need to fill. I need to fill all 4 of those, so this is a problem with AND. I'm not filling the first digit or the 3rd digit. I'm filling first digit, second digit, 3rd digit, and 4th digit. So this one needs to be a letter. The first 2 need to be a letter. Oh no, sorry. The first 1 needs to be a letter, and then the remaining 3 need to be a number. So made up of 1 letter followed by 3 digits. So then we want to think about, well, how many options are there for each of these stages? So the letter, obviously there are 26 letters in the alphabet, so 26 options for that. The numbers, digits, there are 10 digits, 0 to 9, so 10 different options that could go there, 10 different options for there, and 10 different options for there. Given that there's nothing that says we can't repeat the options. If it said that it had to be 3 different digits, then obviously there'd be 10 options for the first digit, only 9 options remaining for the second digit, and only 8 options remaining for the 3rd digit. Okay, so 26 times 10 times 10 times 10 is going to be 26,000 different safe codes. How many more codes would there be if the safe was changed to require a code made up of 2 letters followed by 3 digits? So obviously this time we've got 5 positions in our code. We're going to be multiplying because we need something in each of those positions, so it's an AND problem. 26 letters for the first choice, again 26 letters for the second choice, and then 3 tens. So that gives us 676,000 different codes. So you see the number of codes increases quite rapidly just by adding an extra digit. Okay, example 5. How many different 3-digit numbers can be formed using the digits 1, 2, 3, 4 and 5 if the digits cannot be repeated versus if the digits can be repeated? Okay, so this is what I was talking about with the code before. So we've got a 3-digit number. We need to have a number in each of the 3 positions. So it's an AND problem, so we're multiplying. If we can't repeat the digits, then the options for the first digit of the number, there's 5 options for the first digit of the number. Then I'm not allowed to repeat. So whatever digit I've used in the first as the first digit is done, and I now only have 4 digits left to choose from for the second. And then 3 digits remaining for the third option. So we have 60 different options if we can't repeat the digits. If we can repeat the digits, we're going to have more options. So if we can repeat the digits, again we've got 3 digits in our number, we need numbers in all of them. There are going to be 5 options for each of the positions. So we're going to have 125 different numbers that can be formed if we're allowed to repeat. Okay, so in summary, generally you're looking for, is this an OR situation or an AND situation? Am I looking at that or that, in which case I'm going to add the number of possibilities, or am I thinking about, well, I need that and that, in which case I'm going to need to multiply the possibilities. So the first exercise is in your booklet. It'll be exercise 2A with some similar problems as we've just looked at involving the addition and multiplication principles.